Okay, today we're going to do something a little different. We're not just going to solve an exam question. Nope, we're going to get inside the head of an examiner. We're going to tear apart question 7 from the AQA GCSE Physics paper and find all those little clues that lead to full marks.
So here's our game plan. First up, we'll decode the question, figure out what they're really asking. Then we'll get into this whole mass limit mystery, trace the path of the energy, absolutely nail the calculation. And then, this is the best part, we'll put together the ultimate examiner's checklist. You'll know exactly what they're looking for.
All right, first things first. Before we jump into any answers, we've got to get our bearings. The key to any physics problem is really understanding the setup.
Okay, so here it is. Figure 7, straight out of the exam paper. It looks simple, right? A baby bouncer. But an examiner sees a goldmine of physics here. You've got these two key moments, position A up high and position B down low. And everything that happens between those 2 points, well, that's a whole story about forces, energy, and elasticity. Let's dig in.
Okay, let's dive into the first part of this question. What's so interesting here is that it's not a math problem. Nope, this is all about your conceptual understanding. Can you take what you know about physics and apply it to a real-world warning label?
So the question's pretty blunt, right? Suggest one reason why a baby over 12 kilos shouldn't use this thing. Now, a lot of people get tripped up by that word reason. It's almost like a trick question, because the examiner is tempting you to give a simple, common sense answer, but what they really want is a physics reason. So let's think like a physicist. What could actually physically go wrong here?
Okay, and this slide right here, this is the absolute heart of good exam technique. If you write something like, the baby might get hurt, you're getting a big fat 0. And you might be thinking, but why? Well, it's because that's not physics. The examiner needs to see that you understand the science behind it. So when you say something like, the spring may become permanently extended, boom, you're showing you're thinking about the physical limits of the equipment. And that is where the marks are.
And here you go. This is basically the examiner's secret checklist, pulled right from the official mark scheme. Just look at how precise this language is. Permanently extended, that's not just a random phrase. That's talking about the elastic limit. The harness may break. That's all about tensile strength. See, every single correct answer is tied directly to a core physics concept. It's not just about being right, it's about speaking the language.
All right, on to part 2. I kind of like to call this the storytelling question. You're not just spitting out facts here, you're actually telling the story of energy as it changes from one form to another during that bounce. So your job here is to be an energy detective. We're tracking its journey from the moment the baby is still at the top, position A, all the way down to when it's still at the bottom, position B. A really complete answer needs to cover what's happening at the start, in the middle, and at the very end.
And this slide just lays out that whole story perfectly. We kick things off at position A. The baby's up high, so it's all about height, right? That means maximum gravitational potential energy, or GPE. Then as the baby starts moving down, that GPE has to go somewhere. It starts transforming into 2 things at once: kinetic energy, because of the movement, and elastic potential energy as that spring starts to stretch. And finally, when we hit the very bottom, position B, the baby stops for a split second. All that motion energy is gone, and every last drop of that initial GPE is now stored up in the spring as elastic potential energy. It's a perfect transfer.
And wow, this right here is pure gold. This is the exact wording from the mark scheme. You can see it's like a little 3-part story. Part 1, you identify the GPE at the start. That's 1 mark. Part 2, you explain that it transfers to both kinetic and elastic potential. That's your 2nd mark. And part 3, you state that at the end, it's all elastic potential. That's your 3rd. You see? Tell the whole story, you get all the marks. Simple as that. All right, time for the grand finale, or switching gears now, moving away from concepts and into the cold, hard numbers. It's calculation time.
Okay, so let's lay out the facts. The problem tells us we have 4.0 joules of elastic potential energy, and the spring has stretched by 8.0 centimeters. Our mission is to find the spring constant, which we call K.
To crack this, we got to pull the right tool out of our toolbox. We look at our physics equation sheets, and there it is, the formula for elastic potential energy. E equals 1/2 times K times E squared. This equation is the key that's going to unlock this whole problem.
Whoa, hold on a second. Before you even think about picking up your calculator, you have to spot the classic examiner trap. Look, the formula needs the extension in meters, but the question gives it to you in centimeters. I'm telling you, This is the #1 spot where students lose marks on these kinds of questions. So our first and most important step is to convert 8.0 centimeters into 0.080 meters. You get this right, and you're halfway there.
Okay, now that we've fixed our units, we can get down to business. Step 1, we plug our numbers into the equation. Step 2, we simplify things a bit by squaring that extension. Step 3, this is the algebra part. We rearrange the formula to get k all by itself. And finally, step 4, we do the math and solve it.
And there it is. Our answer is 1250. But wait, an answer without units is like a sentence without a period. It's not finished. It's 1250 times newtons per meter. Seriously, don't throw away an easy mark right at the finish line. Always, always include your units. That's what a pro does.
So, we've completely taken this question apart. What are the big lessons here for your exam technique? Let's pop on our examiner hat just one more time and build the perfect checklist. Think of this table as your ultimate cheat sheet for scoring high. For that first question, the mass limit one, it's all about elasticity, so you've got to use those precise physics terms. For the energy question, it's about the transfers, so tell the complete A to B story. And for any calculation, the absolute golden rule is check your units and convert them before you do anything else. You master these 3 things, and you're not just answering the question, you're thinking like an examiner.
And I'll leave you with one final thought to mull over. The question made life easy for us, right? It told us to ignore energy dissipated. But in the real world, things aren't so perfect. You've got air resistance, you've got heat. Energy is always getting lost. So how would that change the problem? When you can answer that question, well, that's when you know you've gone beyond just passing the exam, and you've started to really, truly understand the physics.